So we're going to start with Unit 2. So I also posted these on Google Classroom. So if you look, these are all extra videos. So if you need help on any other like specific topics, these are like Bozeman videos mostly.
Yes, ma'am.
These are flashcards if you want to go on like Quizlet to practice some of the terms. That's what these are for. And then we're going to start with topic 2.1. So it's been a hot minute since we did topic 2.1 or any of the two topics. I took notes on one of these. It's fine. All right. So the first thing we need to look at right here is you're going to be asked to compare biodiversity. So just looking at these two, would community A or community B be more diverse? B. Can someone tell me why they think it?
Because there's a variety of different ones.
There's a lot of different ones. Good. So we check biodiversity through genetic means, species, habitat, and ecosystem scales. So the more genetic diversity there is, the species is how many different species are in that community, how many different types of habitats are in that community, and different ecosystems. So if there was like a water, like a river through here, then there would be a forest ecosystem, and there would also be like a river ecosystem. So the more of these things there are, the more biodiverse an area is. So you need to make sure that you memorize these 4 things. You will be asked what scales can be used to measure biodiversity in an ecosystem. And it will be these genetic, species, habitat, and ecosystem scales. Do we think we could answer a question like this on the test?
Yes, ma'am.
All right. So topic 2.2, ecosystem services. On your personal progress check, we really struggled with this one. So basically, this is anything that nature does for us. We call it an ecosystem service. So provision, it provides food for us, water, wood, and fuel. These are things that nature provides and we get that benefit from. Supporting is going to be anything that an ecosystem provides for the living things that live in it, not us, but them. So allowing for diversity, so allowing living spaces for them to live, that is a supporting service. Regulating is going to be anything that the environment does to regulate air quality. This is also going to be controlling floods. So like trees, mangrove trees will absorb water and that helps with flooding in salt areas. Or like bees do crop pollination. That is a regulating service. And then cultural services are things like we go hiking for enjoyment. These are any things that we're going to enjoy out of nature. That will be a cultural service. Even just like looking out and it's pretty, that's a cultural service. And if you have questions, just stop me and ask, okay? All right. 2.3 island biogeography. That was the lab where you threw things at the plates and the hula hoops. So remember, that is just the bigger and closer, the more diverse an island will be. The smaller and the farther, the less diverse it will be. So one question might be, which of the following would most likely experience the greatest decline of specialist species if an invasive species immigrated from the mainland? So which one of these islands would struggle if an invasive species came to it?
The smallest one.
This small little one. This one right here would struggle. If anything changed, this is going to be the one that struggles. All right. Another way they could phrase that question is on the next slide. So a 163 square kilometer small island is found 2,000 kilometers from the mainland. A second larger island is found closer to the mainland. It's giving you distance. Based on the theory of island biogeography, what is most likely true about the small island when compared with the large island? Is it more or less biodiverse? Less. Is it going to, which one would be disturbed the most? What did we talk about? Which one will be disturbed the most by anything?
The smallest.
The small one will always be disturbed the worst. Alright. So ecological tolerance is just the range that a species is going to thrive at. So there's going to be, if it changes, if it's an aquatic animal, if the pH of the water changes, they'll die. If it gets too basic or too acidic, it would die. Or if the temperature gets too hot or too cold, something will die. Say like a polar bear. If it's gonna wanna be on the cold side, right? If it gets too hot, what might happen to a polar bear? It's going to die. You're also going to be asked to look at a graph and just tell me what is this range of ecological tolerance. So basically, if you're looking at something and they all die and then they all die and then they start living, that's its ecological tolerance. If there's 0 organisms in an area, that means they can't tolerate it. They're dead.
Whoa.
That's all you're gonna have to be able to tell me. All right. Natural disruptions to ecosystems. I'm not going to ask you about short, quick, long, slow, any of that. What I am going to ask you is how things come back from a disturbance. So what are some disturbances in an ecosystem?
Forest fire.
A forest fire is a disturbance. What else is a disturbance?
Hurricane.
Hurricanes. Flooding is a disturbance. Tornado. Deforestation. Humans building a road through their ecosystem. Those are all disruptions. Are they going to, is a species going to come back faster from a forest fire or from a tornado?
Tornado.
Come back faster?
Mm-hmm.
I say forest fire.
A forest fire?
Yes.
Okay, why?
Because if they get caught in that tornado, they can end up anywhere.
It could end up anywhere.
Forest
Okay.
fire, they just gotta get away from fire, but like they can come back once it's all over.
But wouldn't all the resources be destroyed in a forest fire?
In the
I'd
forest.
rather have all my resources be destroyed and get new ones than be flung somewhere I don't belong.
Be flung somewhere. Yeah.
Mhm.
So if
That's
they're
what
flung,
happens.
they're dead.
Mhm.
Okay.
But
But basically, most natural disruptions, they will come and find a happy balance again. It's gonna take some time. None of the questions on that one are difficult, promise.
So which one was right though?
Hmm?
What would they survive you with?
The fire. All right, the next one, adaptations. The questions are basically going to ask you what adaptation would cause this organism to survive better in an area. So anything that is going to allow them to survive better, that will change in their population. This is just a basic biology question. Alright. 2 point, yeah, this one right here is also adaptations. So this one right here, that's a question talking about how finches are going to change over time based on the food that's available to them. But what the question is going to ask is what is an average beak size? And the graphs will all look like this. And the way you read that is this dotted line is the average. So what would be the average beak size for this population?
10.1.
Around 10, 10.1. That is going to be the average of that, the average beak size. Okay. And then lastly for unit 2 is going to be primary and secondary succession. So things that you might want to jot down is primary succession is going to happen, it's going to grow back from no soil. This is growing back from bare rocks. So a ecological disruption that would cause a community to need to go through primary succession. Can anyone think of something that's gonna knock it all down to rock?
Wait, what
The
did you
flood.
say going back from what?
Rock.
Volcano.
Volcano eruption is gonna be one example that's gonna lead to primary succession. And another one is a glacial, like a glacier moving away from land. It's just gonna leave rock under it. So glaciers and volcanoes. That is going to cause primary succession. Secondary succession begins with soil. The soil's already there. Everything they need is there. The disturbance that would cause it to need to go through this would be like a fire. Fire is gonna cause an ecosystem to need to go through secondary succession. Tornado would also be another good one.
Hurricane.
Hurricane, yes. All of those, you still have soil. And that's the end of unit 2.